My name is Shreya, and today I'll be going over this problem. How many 5-digit positive integers exist where the digits are non-increasing from left to right? Stars and bars is a common technique that can be used with these types of problems. I'll take an example where there are 6 cookies and 3 children. Each child has a pile of cookies, and between those piles there's a separator on the table. So, given that there are 6 cookies and 2 separators, we can look at the slots where we can put the separators. And also keep in mind that if 2 separators are next to each other, that can mean that either 1 or 2 children don't get any cookies. So there are 8 spots to put these separators, and there are 2 separators. So we can use 8 choose 2. Alternatively, it's an equivalent form could be to place all the cookies, which would be 8 choose 6, which is equal to 8 choose 2. 8 choose 2 can be written as 8 factorial over 8 minus 2 factorial times 2 factorial, which then evaluates to 28, as I've shown here. The general formula for stars and bars, given that we have n cookies and m children, is n plus m minus 1, choose m minus 1. Now, we want to look at how we can use stars and bars to solve our original problem. So think of it as we have a set of 5 different digits, and we just need to look at how many distinct sets there are, because given that we have a set of 5 positive digits, we can assort them so that they fit our constraint. And now, applying stars and bars, we can think of all of the different digits as 10 children. And then the number of digits that we want to have, so that would be 5 because each number we have has 5 digits. So that turns into 5 cookies. As shown before, if we have 10 children, that means we have 9 separators. And then we have 5 cookies. So now we want to find how many different assortments of this can we have. So to do this, we'll do 9 plus 5. Choose 5. That will give us 14. Choose 5. So we can write this as 14 factorial all over 14 minus 5 factorial times 5 factorial. This is also equal to 14 factorial over 9 factorial times 5 factorial. And this will end up evaluating to 2002. So can we stop here? That's a good question, but no. So we have to think, do we have any exceptions to this case? And here, when we're making our sets, we need to consider the possibility of having 0, 0, 0, 0, 0, because when you write that out, it's actually not a 5-digit positive integer. So we need to remove that one case. And fortunately, there are no other situations where we have a set that doesn't qualify for our constraint. So we have to do 2002 minus 1, which then gives us 2001. And that's our final answer. That's how many 5-digit positive integers exist where the digits are non-increasing from left to right. Thank you.